Let's graph sine and cosine. So, what are sine and cosine? Well, if you remember your unit circle, you know that sine at 0 is 0, and sine at pi is 0, and sine at 2 pi is 0. Then at the top of our unit circle, when we're over here at 90 degrees, or pi over 2, so this is x coordinate of pi over 2, sine is positive 1. And down here at 3 pi over 2, we have sine is negative 1. So this is what one cycle of sine looks like. And sine is a periodic function, which means it repeats every period, so every 2 pi it repeats. And this is an example of 2 cycles of sine of x. Let's do the same thing with cosine. Cosine starts as 1, and at 2 pi again it's 1. When the angle is pi, cosine is at negative 1. At pi over 2 and 3 pi over 2, cosine is at 0. So this is what our cosine curve looks like. Looks very similar to your sine curve. In fact, it is the complement of the sine curve. And when we use the fact that cosine is also periodic, we can repeat whatever our cosine's behavior was in the first period, and here is a second cycle of cosine. So how do we deal with this when it's not just sine and cosine? So whenever we have a trig function, and for this we're just going to be talking about sine and cosine, we will have vertical shift, amplitude, phase shift, and period that are based off of these parameters. The vertical shift is based on whatever's being added. Now, these things don't have to be in this order. If it's d, if we are adding something first, if we add 3 plus some trig function, it still counts as d. But the vertical shift is based off of going up by d, positive d. And what I think of that is our equilibrium line. Wherever the x-axis was, that was our original equilibrium line, and then it gets moved up or down based on the value of d. Amplitude is a, so this is a stretch a vertically. So that's how far does the curve deviate from the equilibrium line. It deviates by 1 in our original functions, but we could multiply it by something and stretch it more. Phase shift is by negative c over b, which is and that's to the right, but usually we have a negative value. If we have a negative value here, then obviously it will be to the left. This is based off of what will make bx plus c equal to 0. Well, if we subtract c from both sides, we get bx equals negative c, and x equals negative c over b. So if there's something more complicated in here, it's whatever value of x makes this 0, that's what our phase shift is going to be. And then for most of our functions, the period is going to be 2 pi in the basic one, and then we're going to divide that by b. However, specifically, this video is about sine and cosine, but specifically when we have tangent or cotangent, for tangent or cotangent, we're going to have the period be pi over b. So, what does this look like? Practicing this idea. So, first thing I look at is we have an equilibrium line at negative 1, so this is going to be my new equilibrium line. I notice that we have no shift horizontally, so because it's cosine, it will start at a maximum at x equals 0. I notice, so let me write these out. The shift is down 1. There's no phase shift. We have an amplitude of 3, and then based on this 3 here, we have a period of, what would that be? 2 pi over 3. So the amplitude of 3, and this is cosine. Cosine would normally start at 1. It's been shifted down 1, so that's at 0, and the amplitude is 3. So it's going to be 3 away from our starting equilibrium. Then our period is 2 pi over 3, so 2 pi over 3 later, where is 2 pi over 3? That's going to be about here. That's going to be where it gets back there. Halfway between that, it's going to be at a minimum, so that would be at pi over 3. It's going to be at a minimum, and again, that's going to be 3 away based off of our amplitude of 3. Lastly, halfway between these, left-right, is going to be where cosine has an equilibrium point. So here is 1 period of our cosine graph. Let's repeat this. So the next place would be at 4 pi over 3, would be where it happens again. And then if we multiply that by another, if we multiply 2 pi over 3 by 3, we get at 2 pi is another maximum. Halfway between these two is another minimum. Halfway between these two is another minimum. And I'm just going to kind of sketch what's happening here. And it's not a perfect curve, but this gives you the idea of what it is. It's been shifted down 1, stretched to an amplitude of 3. The period was compressed left-right to be a period of 2/3 pi. And there was no phase shift, so because it's cosine, it's starting at a maximum. Now let's do this one. We have a vertical shift down to 1. The amplitude is being moved by 2, so it's going to be between +1 and -3. If I ask you about the range of this function, it would be between -3 and 1. And then our period is 2 pi over 1/2, which is 2 pi times 2 over 1, or 4 pi. So our period is 4 pi. It's sine, so it's starting at an equilibrium point, and at 4 pi it'll be back at an equilibrium point. Halfway between is another equilibrium point, and then we have a maximum and a minimum halfway between those. So here is one cycle through sine. If we repeat this, we'd have 6 pi and 8 pi as our next equilibria. And then we have another maximum. So there's sine.